Well, hello functions. Yesterday we covered this triangle. We found the sine, the cosine, and the tangent of this. So if you recall, we can go back. Let's go back. So when we were looking at this, we found the sine of this was that. So if you don't have this in your notes, make sure you get it in your notes. We have the cosine and we have the tangent. And then we did the same thing for b. So sine of b was the sine, cosine of b, and the tangent of b. So now what I want you to do is I want you to find the cosecant, the secant, and the cotangent values, the reciprocal values of those. So go ahead and hit pause and do that. So these are the values for the cosecant of a, which would be the hypotenuse over opposite, the secant of a, and the cotangent of a. So now I'd like you to do that for all the values of b. And that's what these would be. So we're going to use that idea and we're going to expand on that. But first we are going to talk about cofunctions. So what I want you to talk about, or what I want to talk about with you, are these cofunctions. So go ahead and hit pause and get this in your notes. So what this is saying is that the sine of a is equal to the cosine of 90 degrees minus a. And the cosecant is equal to the secant of 90 degrees minus a. And the tangent of a is equal to the cotangent of 90 degrees. So if we think about this, if we drew a triangle, now this isn't going to be perfect by any means, but if we drew a triangle in standard position, and we said that this was angle A, this was my perpendicular angle, and this was angle B, and this was angle C. Oops, let's go back. Angle C. Then we're saying that, so if we think about this, so these angles, the sum interior of a triangle is always going to be 180 degrees. So we're saying angle A plus angle B plus angle C here, I'll put this angle sign, angle is equal to 180 degrees. But if we know one of them, so if we know that angle A plus angle B plus 90 is equal to 180, then we know that these two angles right here, angle B and angle A, they have to add up to 90 degrees. So that's what we're saying. So if we know those things, then we can take that idea and apply it to all of these. So make sure you hit pause, you get this in your notes. So we're going to do this example. So if we were to find the cosine of theta plus 4 degrees, and that's equal to 3 theta plus 2 degrees, then since they are cofunction, then the equation is true if the sum of the angles is 90 degrees. So that means if we add both of those angles together, then they're equal to 90 degrees. Well, we're not dropping the sine and the cosine, but we are just trying to get these together. So remember, theta is just like x. It's just, but usually it relates to angles. So if theta is just like x, we're going to solve it just like x. Let's combine our like terms, subtract 6, and then divide by 4. So if I were to plug this back into the original, I would get that the cosine of 21 plus 4 is equal to sine, which would be 3 times 21 plus 2. So if I know that, well, then that means that the cosine of 5, because 21 plus 4 is equal to sine of 3 times 21 is 63 plus 2 is 65. And then we just learned that this plus this needs to equal 90 degrees. So then 25 plus 65 does equal 90. So that works. So you don't have to plug it in. I'm just showing you why it works. So let's do another example. So the tangent of 2 theta minus 18 degrees is equal to the cotangent of theta plus 18 degrees. Again, those are cofunctions. And so since they're cofunctions, they have to add up to 90 degrees. So we're going to set them equal, combine our like terms, divide by 3, and we get theta is equal to 30. Okay, so now we're going to talk about special right triangles. I'm going to start with an equilateral triangle. So if we take this equilateral triangle and we bisect it, so when we bisect something, we're cutting it in half, and we're going to do that, we're going to call this a perpendicular bisector. So when we bisect it, it's going to be perpendicular to this side, which will create two different right triangles that are congruent to each other. They're going to be exactly the same. They're going to be congruent. So when we do that, we can actually just take one of them and start solving for this side that we don't know. So to solve for that, we are going to use the Pythagorean theorem, which would be a squared plus b squared equals c squared. So the one thing that I need to make clear is that c squared is always the hypotenuse. The two sides are always going to equal the hypotenuse. So I know the hypotenuse is the 2 because it's the opposite of the right angle. So this is my hypotenuse. Oops, got the little tail for the y. Hypotenuse, which means these are going to be the two legs of the right triangle. So we're going to get 2 squared is equal to 1 squared plus x squared. And I used x squared instead of a or b just because x was given on the triangle. So then we can figure that out. We get 4 is equal to 1 plus x squared. And then we subtract that, and then we take the square root of both sides, and we get x is equal to the square root of 3. So go ahead and get this in your notes. Hit pause. Okay, so now we know that. Now we have all of our sides. Let's take that triangle and let's find, oh my goodness, come on. Let's find the 6 trigonometric functions for that. So that means we're going to find the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. So we're going to talk about that. We're going to do it for the 60-degree angle. When I was learning this, before I start anywhere, I find and locate the angle I'm looking at. Well, I'm looking at this angle right here, which means I need to identify which one of these is my hypotenuse. Well, we already said that the 2 was. So this is my hypotenuse. Then I'm looking at it like a flashlight. It's shining its light. This means it's over here. This is my opposite side, which leaves this side as my adjacent. So I want to do that before I even start. Then I can start setting up my sine. So I'm going to find the sine of 60 degrees. Well, the sine of 60 degrees is the opposite side over the hypotenuse, which is going to be the square root of 3 over 2. Then I want to find my cosine of 60 degrees, which is going to be 1 over 2. Then I find the opposite over the adjacent, which is the square root of 3 over 1. And then I'm going to do the same thing. Let's find the cotangent. So I get 1 over the square root of 3, but I can't have a radical in the denominator. We learned that earlier this week. And because I can't have a denominator in the bottom, I'm going to be multiplying by the square root of 3 over the square root of 3, which gives me the square root of 3 over 3. I'm going to do the same thing for the secant of 60 degrees, which is the hypotenuse over the adjacent, which is 2 over 1 or 2. And then the hypotenuse over then we're going to do the cosecant, which is the hypotenuse over the opposite side, And again, we have that square root in the bottom, which we can't have, so we are going to do the square root of 3 times the square root of 3, which gives us 2 times the square root of 3 over 3, because the square root of 3 times the square root of 3 is 3. So that is how we're going to find different angles. We're going to do the same thing for this Pythagorean, or for this 45, 45, 90 triangle. So if I have a 45, 45, 90 triangle, then if I do 1 squared plus 1 squared equals r squared, then I end up with 2 is equal to r squared, which is r is equal to the square root of 2. So then we're going to find the sine, the cosine, the tangent. So here we have the sine of 45 degrees. Now, one of the things that's really nice about a 45, 45, 90 is that this is always going to be the hypotenuse, because it's the opposite of the 90-degree angle, but I can choose which one I'm looking at. So if I decide that this is the angle that I'm looking at, this 45 degrees, then this is going to be my opposite, and this one will be my adjacent. But guess what? It doesn't matter because this is the same, because this is a 1 and this is a 1, so we're okay. So if we do that, we get 1 over the square root of 2. Again, we can't have that radical. Remember I said at the beginning of the week, we're going to get some natural practice of getting rationalized fractions. So we're going to multiply by the square root of 2 times the square root of 2, and that's how we get a square root of 2 over 2. To find the cosine of 45, we're going to get the 1 over the square root of 2 again, which means we have to have the square root of 2 over 2. Then we're going to get tangent, which is just 1 over 1 or 1. Then we have the cotangent, which is just 1 over 1, or 1. Then we find the secant, which is going to be the square root of 2 over 1, or just the square root of 2. And then we get the cosecant, which is the cosecant of 45, which is going to be the square root of 2 over 1. So when we do these, we're going to be using these a lot. I'd like you to put this table in your notes. So go ahead and hit pause and get this in your notes. And then we've actually already figured out 45 degrees and 60 degrees. We have the capabilities and we are able to find 30 degrees, but we're going to fill them out. So those are going to be the special ratios of of a 30-degree triangle. We've already figured this out. We just did that on the last slide, and then we did this one on the slide before. So this is the last thing that we covered in class. You should be able to do 1 through 18, I think. You do need to have 1 through 15 done by Monday. If you have any questions, please let me know. Otherwise, you have a great weekend, and I will see you all later. Bye, functions. Oh, also, don't forget to hit like or subscribe. You're never going to be a YouTube star if you don't do that.